All right, we're going to take a look at one of the most fundamental components of understanding algebra, and that is the idea of functions. So, let's just take a look at, we're going to work through several examples here with one function in mind, or actually a couple functions in mind. So I'm going to define a function f of x is equal to 2x plus 3. So just a really basic linear function. Not super interesting, but it's going to be good enough for us right now. So the first time that you might have been introduced to functions, you might have seen these as, or trying to understand them as this idea of a function machine. And this is a really kind of great descriptor of what's going on here, because this idea is really what's going on with my function. So what a function machine does is that it takes in inputs and then it outputs something based on what this function is. So in this case, what does this function do? F of x, it takes the value that I'm plugging in for x right here, and then multiplies it by 2 and adds 3 to it. So, for example, if I take f of, just go with 3, what it's going to do is 3 is going to go into my function machine. Something is going to get done with it, and then I'm going to get something output. In this case, what will be output is 2 times 3 plus 3, which is going to be equal to 9. So in this case, 3 goes in and 9 comes out. And we typically look at these all as, kind of plugging numbers in and getting a value back out. But really, we could plug in whatever we want. So for example, I could plug in a different variable into the function machine. So f of a, when I plug a into the function machine here, the same thing is going to get done with it as before. Is I'm going to take a, I'm going to multiply it by 2, and then I'm going to add 3, because that's what the function machine says to do. I multiply by 2 and then I add 3. So I'm going to get out 2a plus 3. And there's nothing I can do to simplify this here. This is in a simplified form. And really, this is the exact same thing as my function that I had previously, just with a different variable. But let's say we want to plug something else in terms of a variable, not just a variable itself. What if I want to take f of a plus 1, for example? Well, so if I plug in a plus 1, the exact same thing is going to be done in that order. I'm going to multiply by 2 and I'm going to add 3. So I'm going to get 2 times a plus 1 plus 3. Or maybe if I want to simplify this, this would be 2a plus 5. And so whenever I plug in a plus 1 in my function, what I get out is this. And then, I could even plug in, let's say, if I want to plug in f of 2a. Well, the same thing. This is going to be 2 times what I'm plugging in, 2a plus 3. And so this would simplify to 4a plus 3. So I can plug in whatever I want. And so now here's the first tricky part is, well, if I wanted to, I could talk about kind of plugging in other functions. So let's say that I had a new function. Let's define a new function here. This new function is going to be g of x, and it's also going to be a simple function. It's going to be just x squared. Simple as that. And so what I could do is I could talk about plugging in a value from g of x into f of x. And so the way that I would write that, I could combine these functions into something that looks like this. So I could say f of g of x, which is different than g of f of x. These are two different things. So let's take a look, and we'll draw out our function machines again. Let's take a look at f of g of 3. So what I'm saying here is that order of operations, I got to do this inside part first. So in other words, what I'm going to do is I'm going to have my function machine here. This is g of x. It's going to take in my input, and it's going to output something. But then that immediately is going to lead into my new function machine. I feel like my machines are getting worse as I go. F of x. So what's going to happen here is if I plug in 3, maybe I'll use a different color, plug in 3, that's going to go into my function machine. So what comes out? Well, I'm going to take g of x, so g of 3, and I'm going to square it. So outside of this function comes 9, and that will get dropped into f of x then, which is 2x plus 3. So when I plug 9 in for that, what I will get is 18 plus 3 is 21. So f of g of 3 is equal to 21. This is a little bit confusing because, I mean, the way we read this is we read the f first, but that's not actually what's getting done first. What's getting done first is the inside part, the g of 3 here. Okay, so this is a little bit different than if I would have flip-flopped these. So what if instead I have g of f of 3? So now I have f of x first. So that's what I'm going to actually do first. That's going to have its output. And then I'm going to take g of whatever that number is that comes out. So this is g of x. So in this case, let's do the same thing. Let's do g of f of 3. So g of f of 3. And so when I plug in 3 into this function, well, what does f of x do? F of x takes 2 times that number, so 6 plus 3, so that's 9 is what I get out. And then that 9 goes into x squared. So 9 squared is 81. So g of f of 3 is different than f of g of 3. These are two different values. So again, we can plug in what we want here. Another way of thinking about this, so let's say I didn't want to go through this process every time, and I just want to think of it, just tell me what f of g is every single time. And I can do that. I can do that by kind of working with these functions. So instead of what is going into f of x here, well, g of x is being plugged into f of x. So another way of writing this is if I want to rework f of g of x, well, what is g of x equal to? G of x is equal to x squared. So what this is equivalent to is f of x squared. And so now I can plug that into f of x now. I'm going to multiply by 2 and add 3. And so what this is equal to is 2x squared plus 3. Now we can also take a look at, well, what is g of f of x then? So g of f of x is going to be equal to, so what is f of x? F of x is 2x plus 3. So this is g of 2x plus 3. And then if I take that 2x plus 3 and plug it into x squared, or g of x is x squared, I'm going to get 2x plus 3 squared. So this will be equal to 4x squared plus 12x plus 9. And so now, if I wanted to calculate what g of f of 3 was, I could just plug in 3 into this new expression and be happy. Same thing if I want to take f of g of x. So these are just different ways I can combine functions all together. And so what I really want to get at is this idea, so this new idea of inverse functions. So let's actually make a new page to work with. So this idea of inverse functions. So whenever I have a function, let's just stick around with f of x is equal to 2x plus 3. My question is there a function that kind of undoes what f of x does? And the answer is yes, there is one. And the way that we write is that this is going to be f inverse. So we use this little negative one. It's the inverse of x, so f inverse of x. You're right, the inverse of f. And so the question is, how can I figure out what f inverse is? Well, so I'm just going to kind of think through this logically. Well, if every time I take f of x, what I'm doing is, number one, I am multiplying by 2. And then number 2, I am adding 3. And so what I want to do whenever I'm trying to take f inverse is I want to undo all these operations. So in this case, what was the last thing I did? I added 3, so let's undo that. So number 1, I'm going to subtract 3. And number 2, what did I do before I multiplied by 2? So I'm going to divide by 2. So what does that look like? Well, that means that f inverse of x is going to be equal to, so I'm first going to subtract 3, and then I'm going to divide all that by 2. And so these two functions are inverses, and we can justify it here. Let us take, let's go with f of 3, because we keep using that value. F of 3 is equal to 2 times 3. Well, let's write it out. 2 times 3 plus 3, which is 9. So what I just said is that my f inverse function, though, what it should do is undo everything that this function just did. So in other words, if I take f inverse of 9, what should happen? Well, this should be 9 minus 3 over 2. 9 minus 3 is 6 over 2, and that is 3. So what I should get, and what I did get, is what I plugged into f of x before, because these are inverses of each other. It undoes the things that this function just did to it. So if I plugged in 3 and got out 9, I plug in 9 to the inverse, I should get back out 3. And this should work for any values I plug in. If I plug in a number, get some type of output, I can take that output and put into the inverse function and get the opposite of it. And one more way that I can kind of make sense of all of this is, well, let's just look at this. So this is called, I haven't actually used the phrase yet, but function composition. Let's use some function composition here. So what is f of f inverse of x? Well, so f inverse of x, we just said, is, where is it? X minus 3 over 2. And so then I'm going to multiply this all by 2 and then add 3. So I'll multiply this all by 2, because that's what f does. X minus 3 over 2. And then I'm going to add 3, because it was 2 plus, and then 2 times, and then plus 3. And so if I then simplify this, well, 2 divided by 2, that's just 1, so this is x minus 3. And I add 3 to it, and I just get x. So this makes sense, because these functions undo each other. If I plug in a value, and I take f inverse and an f of it, I should get x. I should get the same thing that I plugged into it. And then the same goes if I take f inverse of f of x. Because these two functions, since they are inverses of each other, will undo each other. So that was kind of a lot, but this is kind of important to understanding functions in algebra. The big takeaways is, let's go back to that previous screen. The big takeaways is that functions just take in inputs. They just take in inputs, and then they give me outputs in return. And I can plug in whatever I want. I can plug in numbers, I can plug in variables, I can plug in expressions with variables in them. It doesn't matter. Or I could even plug in another function into a function, and I can simplify these things down. And so what that led me to do then is talk about these inverses, these functions that undo each other. And so if I plug in a number into my first function here, so if I plug something into f of x, like I did here with 3, I got out 9. If I want to undo that, I can take my inverse function, plug 9 into it, and get back what my input was initially. And so these will be helpful to understand moving forward, so we can apply it to some other things.